Hello everyone. Today I want to talk about scramjets and the possibility of future hypersonic air travel and what kind of importance scramjets might hold for this and or ramjets in general. But first up, I hope to make more of these talking videos in the near future as I have a lot of topics that I want to talk about piled up and these videos are a bit more work to make, but I'll still try to make more within the next few weeks. I've got a lot of topics piled up like re-entry vehicles, more about scramjets, space propulsion, hyperloop, and basic astronomy. And with basic here I mean the principles of how the ancient Greeks, for example, figured out the inner solar system. Not entirely precise, but with quite some precision for their time, and spoiler, it's not aliens. But for now, I will be talking about scramjets in hypersonic travel, or even supersonic travel at all, though the definition of hypersonic is a bit vague at times and not really perfectly clear and a bit arbitrary at Mach 5. But to start with, airliners today and most airliners through history, well, not the very early, but most kind of powerful airliners through history have been powered by turbofans. And turbofans can't get too fast. There is, of course, supercruise and there are supersonic turbofans. You can use an afterburner to reach speeds up to Mach 2 and well, the record holder went up to Mach 3 roughly, but that's really a plane only built for speed, and it's not really a feasible speed to aim for any average afterburning turbofan. So most afterburning turbofans can reach speeds of like Mach 2, and the afterburner isn't incredibly efficient. Now you might say scramjets are also not that efficient, but actually in terms of energy efficiency, they're not that bad. Of course, the specific impulse drops as you go faster, since energy is, or power output is just force multiplied by speed, and that is, of course, if you want to be perfectly efficient, the average speed of the air while being accelerated through the engine, but that's getting a bit complicated. But the faster you go, the lower the specific impulse drops, and that is perfectly okay because you're also going faster. And in the end, if you have the same resistant force, if you have, for example, an aerodynamically similar plane and you just fly at a higher altitude where the air is thinner, and you go at a higher speed and the ISP drops accordingly, you'll still need the same fuel for the travel, or roughly the same fuel for the travel, at the same energetic efficiency of the engine. But afterburners really have a low energetic efficiency, so it's not just that their ISP is lower than that of a normal turbofan, but also their ISP multiplied by speed is lower, or their ISP is relatively low even for their speed. And even with afterburners, there's a limit to how fast turbofans can go. These have two reasons. One reason is because there is simply a limit to how fast certain materials can spin. Turbofan engines or turbojet engines, the really critical parts are usually made of special steel alloys. And these can only spin at a speed where the rotor tips are just so supersonic, and that's kind of the limit to how fast you can get this without some really complicated structure and without just being extremely unsafe or risking the rotor to shatter. You can see this if you look into a turbojet engine or turbofan engine. There are these rotor discs, which are essentially structural parts that keep the rotors from disintegrating through centrifugal force, and they already have these weird expanding shapes that are not exactly exponentially expanding, but that get bigger at the center in order to keep less load over more surface, over more cross-section, and thus optimize the speed at which the material can spin. But this also has a limit, and while the speed at which the rotors have to turn within a turbojet compressor isn't exactly the traveling speed of the aircraft, there is a kind of proportional relation between these. So there's a limit to how fast you can go. You can, of course, kind of overspeed it, but then it gets inefficient. You can use an afterburner to overspeed it, but if the compressor doesn't really keep up with the airplane's own speed, it's going to get very inefficient at a point and then eventually flame out. And while, of course, new materials like fiber enhanced ceramics might improve the speed at which the material can spin because you use a lighter, stronger material, there are also just aerodynamic or gas dynamic limits. The typical turbojet compressor, it might theoretically work at hypersonic speeds, but if you have an infinitely strong material or something, but it wouldn't be perfectly efficient, and it's really a technology that works best at sub and transonic speed. And the thing with supersonic travel is that it only really pays off if it goes really fast. It is obvious to anyone who knows very basics about aviation that supersonic airliners are going to be complicated. Developing a working supersonic airliner is going to be a lot of hassle. It's going to be both legally and technologically much more work than just strapping a stronger engine to an A320 and hoping it goes fast. It's going to be really expensive, and for that to be worth it, it has to kind of pay off. And of course, an airliner going at Mach 1.1 would be a nice PR stunt maybe, but for it to really have a big advantage over an airliner that goes at Mach 0.8, it would have to go much faster than just supersonic. It would have to go at Mach 2 or even much higher. No one is going to pay much more for an airliner to be a tiny little bit faster. Supersonic airliner travel will be much more expensive than subsonic airliner travel at first, and if it ever gets less expensive, then this will be due to extremely high speeds. Of course, if an aircraft can do more flights per day, then you can cram more flights into the maintenance cycle, the life cycle, and the economic reamortization cycle of the airplane, and thus essentially split the cost of the extremely expensive high-tech airplane between more passengers. So you might in the far future get it cheaper than subsonic flight, but then also you would have to be much faster than just Mach 1. So at such speeds, turbofans aren't really effective anymore. And scramjets are actually rather efficient for their speed. They don't really reach the ISP of a turbofan, obviously, but for their speed, they have a relatively high ISP and they actually have a good energy efficiency, especially for the state of development they're in right now. Of course, you would have to somehow manage the speed up procedure to actually get the minimum speed of the scramjet, but hybrids between scramjets and turbojets that could do that are actually in development right now, and the typical scramjet problem that you would have to fly in a curve following a constant dynamic pressure is actually not that bad for an airliner. It does make the use of scramjets in, for example, jet fighters rather difficult, but for an airliner, the main goal is of course to travel efficiently, and Although hypersonic aerodynamics are a bit more complicated, more speed still means higher aerodynamic forces, and less air density still means reduced aerodynamic forces, and you still need only that much lift, so it would make sense to climb through the atmosphere, keeping the dynamic pressure relatively constant to travel with the least resistant force and or drag and travel as efficiently as possible given the engine type and the speed, which would fit actually rather nice with Scramjet. And also only breaking the sound barrier at high altitudes might of course help you get around noise complaints or aviation regulations that prohibit supersonic flight. All in all, I think scramjets are the way to go for future supersonic or hypersonic airliners, although a lot of development still has to be done, of course. It is a future technology which is currently still in development, and this I will focus on in the next talk about scramjets, that is current development projects and research projects on experimental scramjets. Now I've still got a few announcements for the next week. Today we will watch the launch of a Soyuz rocket launching a Progress resupply spacecraft to the ISS. You can watch this on NASA TV or my channel just as well. If you miss it, I will of course be uploading the full coverage afterwards to watch later. Then 2 days from now, on Friday, the Progress resupply ship will be docking to the ISS, and on Saturday the Falcon 9 with Bulgaria will launch. I hope you found this talk kind of interesting, and as always, thanks for watching.